Hi all, good morning, good afternoon from sunny Barcelona, and welcome to this Rhino User Webinar. This is Pedro here, and I'll be presenting today this new video about how to use Rhino in our AEC workflows. This webinar is designed to help you understand how geospatial data are formed and how they can help us in creating better and more optimized design for our cities. The speaker, Messios, will use Rhino, Grasshopper, and VisualARQ to bring in geospatial data and investigate the capabilities of informing our design. We will finalize the work by taking our design to Studio 3DX on the web for a design review in 3D. So Marius is specialized in architectural innovation, particularly in smart cities and building information modeling with geospatial data. His focus is on developing web-based collaborative systems that foster collective decision-making among architects, owners, and communities. So nothing else from my side. I'll let him start presenting, and I'll be here in the chat collecting the questions you might have for the Q&A session. So Marius?
Thank you, Pedro. That's brilliant. Let me quickly share my screen, and if you can verify if that's okay. Can you see my slides?
Yes.
Perfect. So, hey all, thank you for joining us today. So today we're going to go through a storyline and a few facts that I quite enjoy from gathering geospatial data from governmental and open source sites to investigating them in QGIS and streaming them into Grasshopper. Then we will convert them into useful tools, and hopefully we can, use it to improve our designing of our cities. At the end, we will load the resulting design in a Studio 3DX scene where I will share with you. And today I prepared a light version of my workflow, and hopefully you will enjoy it as much as I do. I also laid everything down on a handbook that I'm really happy to share with you at the end of the presentation. Now then, geospatial data have an implicit and explicit association with a location relative to Earth. And approximately 90% of governmental source data have a location component. And this is why my focus is on this public geospatial data. In my opinion, a GIS layer must have three things to be useful. First is the projection classification that the globe is conceptually projected onto. Secondly, the coordinates, longitude and latitude, and that indicate the exact location on the Earth. And the third parameter is the inclusion of any information that enriches that GIS layer and adds value for the user. Now, the World Geodetic System, WGS, is a standard used by GIS professionals in cartography for gathering, archiving, and processing geospatial data. It's the same coordinate system used by the GPS we use on our daily lives. Now, what types of data are there? GIS data. Now, GIS data can be separated into two categories: spatially referenced data, which is represented by vectors and raster forms, and attribute tables. Within the first group, we find two different types that we are all familiar in architecture: vector and raster. So how do we gather these data? Some of them are digital, some of them are traditional methods. And if we look, for example, like the hard copy digitization, it requires this small hardware that is called a pack. It looks like a mouse, but it's not, and it traces the maps on a digital table. It's now rarely used. It's used only in cases for historic archiving. Now, in other cases, like the coordinates geometry, surveyors enter coordinates into the database by using a GPS. Now, geocoding is using addresses to extract the coordinates, and those are usually centerline data, such as street center lines, water, and so on. Google Maps does that, for example. Now, similar to what you might find in other 2D formats, GIS data can store vector shapes and hold attributes that gives us a little bit more information to work with. Now, storing this data is sometimes done differently in GIS, and this is important to highlight. So if we take, for example, a school building complex, you might find data in different representations. In this example, we refer to it as multi-part features or many-to-one, because the laboratory buildings on the left are shown with one table entry for each building type. In the single part features representation, there's a table entry for each distinct polygon. Now, it's important to recognize that due to the difference between these two features, the analysis and interpretation may differ. Multi-part to single part conversion often leads to significant errors in the analysis. In the example, we see that the conversion led to registering each building with 80 people capacity, but we know that 80 is the sum of all laboratories. You might find that mistake converted from a GIS layer if we take it into a Grasshopper to stream that data. Now, polygon inclusions are areas in a polygon that are different from the rest of the polygon, but still part of it. So although the assumption is that this is homogeneous polygon that represents the true and complete forestation area, it is often wrong. There are secondary roads passing through walkways, water surfaces, rivers, probably even buildings before the zone changed. So there is a solution to create a polygon for each inclusion, but generally it's not a common practice since it takes too much time to register all these changes when designing for large areas. So we have to use this data. So how we use this data and how we refer to them, it's quite important. In this example, we are looking at a common lands and service department GIS platform where there is a topological constraint on overlapping property plots within the same feature layer. Now, other constraints might include that no more than one point can have the same geolocation in the layer. There are often mistakes when we convert from raster to vector and vice versa, and we have to be careful when we map these data. This is an example of data websites available around the world, and we are constantly updating this map, and we'll dive into it to check some data from Spain. So if we follow this, let's go to the map first. This is the map we generated. I'm attaching the link at the end of this presentation as well. And you can find the governmental data websites. And from that, we're going to go to one that is for Spain. And if we look at all the data formats that refer to geospatial data, there are plenty of them, and most of them can be streamed into the software we're going to show, QGIS. But for today, we'll focus a little bit on this shapefile, SHP. So if we filter that, you can dive into any of these layers and simply download it. I already downloaded this, so I'm not going to click on it now. Another thing that I like to do is to go to these geoboundaries and download a shapefile layer for the administrative boundaries. And I'm going to explain why. So if we switch to QGIS for a minute, we'll see that I already brought these layers of geoboundaries, which is the administrative layers between these cities. And I also dropped in the layer that I downloaded from the governmental website. Now with this, you have tools in QGIS to stream even more data since you know the location that you're looking to investigate. And you can do that by installing a plugin from OpenStreetMaps, and you simply select the location that you're looking for that data. If we run this for a second. So it downloaded 1.5 megabytes of data that are available in OpenStreetMaps. And this is a really easy and nice way to get some data right into your workflow. They're already streamed here. You can filter them out, get more into what the attributes of it hold by double clicking. Oh, that didn't work. Okay. We can look at the information. What is important is what I mentioned before. What is the coordinate system that is used? And then you can go through the symbology and change anything you want by either rule-based or categorized, and even creating your own heat map. Now, but we focus on getting this data from these websites and exporting them quickly and bringing them into Grasshopper. And this is what we're going to do now. If we simply export save feature as, we can use this S3 shapefile. This is what we already downloaded. And once you do that, then we can jump into Grasshopper and load these layers. Now I'm going to show you a project that is the extent of my workflow that I have been working on. And I need to note that I believe that the Rhino and Grasshopper is one of the best communities out there. And I'm really thankful to a lot of people that help bring so much innovation. I think without their contribution, it would be really difficult to set up a workflow such as this one here. Now, in this example in Cyprus, my aim is to fight desertification on an island that often lacks water throughout the year. My aim is to do that by gathering water from the roof structure in the winter, storing it, and making it reusable to all inhabitants inside a large housing master plan. Now, the use of geospatial data was integrated from day one in the design process, and it was automated to find the most optimized location of such a master plan. But most importantly, was made in such a way that it can take full advantage of the area to offer as much back to the community. Now, based on parameters such as high rainwater gathering, desertification levels, housing needs, and even bioclimatic zones, and which, by the way, these are all data available from the Lands and Surveys Department in Cyprus. The problem of desertification is not in one location, though. And I knew I would find myself wanting to use this data again and again. So I turned them into an integrated part of my workflow to investigate different areas on the island without needing to do the whole iteration again. Now, when the location was found, the structure, including the roof, was adapted to the geomorphology and environmental habits of the specific location. The last thing was to create a feedback loop and bring more data back into this design. And I used the environmental layers to run simulations of a structurally stable roof based on a minimum housing units, square meters of each inhabitant, amount of greenery on the roof, and so on. Now we're going to jump into Grasshopper directly and look at the light version of this workflow. So what we have here is we're using quite a few plugins here, but the most important one for streaming our GIS data is this one that is called Heron. Any information you might need on that, they have a really nice Discord channel that they share updates all the time. So how we start with this is to set up the reference system, meaning that Rhino works in XYZ, the world works with coordinates. How do we map that? And we do that by setting up this component to set the spatial reference system. And this is the one we use. How do we know that? This is what we saw earlier in QGIS, where we go in the information of the GIS layer and we simply look at the coordinate system that is used to map that data. Now, once we do that, what I generally do is, because at the end we're working on site location, right? We're looking at something specific and we want to investigate what is in the surrounding. And with that, so I set up the longitude and latitude of my project as the Earth origin point, meaning that everything will be set as the main location around that site. Once we do that, I brought one layer that will indicate how everything looks. And this is why I brought the Hydro C layer, and you get this outline of Cyprus. Now, once we have all that set up, what we're going to be looking at is selecting the location. So I set up my workflow so that I can set one manually. I can select one if I'm doing, an investigation in general by remapping and reparametricizing this MD slider, or reverse the address. So geolocate which is my location based on a building, based on a famous street, and it will indicate me to the right direction. And for example, of this restaurant, I get two locations, but I already know more or less which is the one I'm looking for. So I choose it with my list item. And the fourth way is to select again the location with the coordinates. Although I set up my environment in another location, which might have been the previous project, I can simply switch to another one because my workflow covers the whole island. And this is what you get. This is the 4 ways of getting the locations. This is the manual one by address, selecting the boundary, reparametricized, and the location with the coordinates. Now, to indicate exactly what I was referring to, it's important to show here that we stream the data for the whole island, but we select which ones to use in our workflow by narrowing slowly down which ones to use. But I highlighted this one because this is all of the buildings in Cyprus. And let's quickly turn that on. It takes a second to compute. And this is what you get. You get the points that refer to these vector outlines of the buildings for the whole island of Cyprus. And of course, that's unusable for us, except if we're doing a huge survey map or exporting something to indicate generality. But what we are looking for now is a little bit more specific. So we're going to preview that off and start previewing this Heron component, which is called import vector. And with that, you can see in the tooltip that includes shapefiles, GeoJSON, OSM that we saw earlier in QGIS, KML, and many others. Now, with this, we need 2 inputs, which are quite important. We need the boundary to constrain the data. And this is where what we have to do in order to filter from all those data to our specific site. How I do it, I simply, let me quickly show that. I tessellate the whole site into these large segments. And with the help of the location that I chose, I can call the pattern and find the one that I'm referring to. And it will take me down to this box here. Now, this component loads the boundary. And you see, this is a really nice component from, I think it's from MetaHopper, where you have a relative path. So I used exactly the same workflow on another computer, but because I brought the data not referenced in a specific path, but referenced in the folder that this Grasshopper lives, it makes it easier to move from place to place or even work from different computers for the same Grasshopper script. Just a small tip there. So with that, we import this GIS layer, which is the build environment, and we filter out this specific area. Let me quickly take away the location text. Okay. I bring more layers in, like the road network. And this is the center of Cyprus. And for those that don't know, Cyprus is a divided island. So you would have a buffer zone in the middle, which is generally called green line. And I brought this specific layer from a survey that was done on site. And this is a division buffer zone that passes through our site here. So you can bring, this is a different type of layer that was surveyed in a different way than the rest. The rest were governmental layers. This one was surveyed, and we still made it with the same reference system so that it matches. And by simply bringing it in, it will go to that location we're looking at. And you can federate all of these GIS layers. Now, we have some quite interesting data that we brought in for this location. We have a noise map, which we can show. And we visualized it in a 3D form. So what we did here was to get a GIS layer that refers to the noise data, and that is in decibel, and it starts from 40 decibels and it goes up to 80, which is quite loud for building areas, build environment. And we filter that category and simply surface it out, filter all the ones that are above average in order to mark the ones that we're going to use in our design. You know, you might want to introduce a different facade to divert the noise, or even, you know, a build envelope where you can use that in your advantage. Now, what I enjoy doing is to taking these 2D data and looking into their attributes that we have inside. So in this case, these are the buildings, and we have building codes, we have the height, the area, and even sometimes the names when it has a significance for the city. Now, unfortunately, we don't have a lot of informed heights in Nicosia, so I use some random height builder in order to get an approximate that we know in the area. Other ways to get real data would be to scan the area and bring that data in. And I'm happy to share how you would do that. So with that, we bring in an extrusion of our buildings, which we generated. The plot footprint is correct, but we don't have the height data, so we bring in this random approximation of numbers to get a good indication on what we are looking at. Now, with that, we do a similar approach to the street. We take the center line of the street, and this is what I was referring before. In GIS layers, you won't get this offset of lines to indicate a street. You will get a center line, and then you have to do the work in the design software to bring that into a more realistic world. And this is what we do. We offset, we loft, we extrude, and generate these streets that we have in the surrounding. Now, I take these buildings, and what we do is to run a sun path analysis. And probably you are familiar with Ladybug components. This is the example file that I got from their folder, and it does a really nice job of bringing this sun hour analysis into our investigation here. So with running this analysis, you get a really nice visualization of the site. Let me make this a little bit bigger. And you see that in Cyprus, especially in the cities, you get a lot of sun in plots even with surrounding buildings, because they are not high in their height, and you don't usually get this obstruction. So with this data, we're going to try and introduce some building that was generated with the sun analysis. What I mean is that we don't focus so much at this stage, which is an early stage in our investigation, on experimenting or making a fully parametricized model, but rather we take these parameters that were given from geospatial data and we embed them into our design process. And this is where you get this preliminary design. I made a simple approach with bringing some walls. And what we did was to find the selected sun hours from 1 to 11 hours per day and isolate that in order to exclude it from our design. So the most exposed are excluded from our design. And this is a building that we get. I can also bring the numbers in. This is from the sun analysis. We map the numbers. And the center line is obviously the most exposed in this site investigation. Now, of course, this is not perfect, meaning that what we have to do now is take the building itself that we introduced and run the same sun analysis. And this is what we did, because this makes more sense when you're looking at it from both perspectives. So building up this feedback loop is quite important. Oh, so I didn't run the analysis. I'm going to run it now. Hopefully it won't take too much computational time. And this will include the building we just introduced here. This building was done by tessellating the site and finding the center of each tessellation and matching it with the day sun analysis. Okay, so this is a new direct sun study with our building inside. So again, trying to build a useful feedback loop in order to have more variations and more useful data in your designs. That's it. That's a small workflow. I didn't push it further, but you could do and introduce all these data from various sources, convert them into tools in a geometrical sense, and obviously take that and bring more useful designs. Now we're going to move towards taking this design that we did and introducing it to Studio 3DX, which will make it easy for us to host a scene and have a meaningful discussion on that. So in order to do that, I'm going to bring over our Studio 3DX, which I'm happy to say that we introduced uploading directly 3DM files today. Yeah, so we were holding it until this webinar. So what we did here was to export this from Grasshopper, bake them into Rhino as geometries, and then uploading them inside Studio 3DX. Now with that, we've built also the plugin that, again, we're happy to share, that is called Studio Rhino Command. And we already activated the port so that Studio 3DX can communicate directly with Rhino. So if I export that, we go to perspective. And if we open this in a new tab, I would also like to share this link with you all. You can join us in this session here. So feel free to join us in this scene. So what we have here, we have Harry, my co-founder, on the inside the scene. And if I simply, thank you guys for joining. That's quite interesting. I'm going to follow Harry so that you can see with my share screen what it does once connecting Studio 3DX and Rhino. So Harry, can you take us for a spin? Okay, nice. It takes a second. Probably I should check my camera. Viewport properties. All right, so we change a little bit the focal length, but you see the direct connection between orbiting inside Studio 3DX and in Rhino 3D. It takes a little bit of time now because we are on this call, but I assure you that it works seamlessly once you have a normal discussion. I think with Studio, thank you again for joining. I can see that it's already more than 20 people joining here. And Pedro, thank you very much. I'm happy to answer any questions, by the way, and share the information that I talked about.
Okay, thank you very much, Mario, for your presentation, and happily that you achieve importing these 3D files in Studio 3DX.
Yes, thank you very much.
Today, so great work. So okay, I don't know if anyone from the public has any question for Marios. So a user TA wanted to see again the link to the example file again.
Yeah, sure. Previously. Which example file are we talking about?
I'm not sure. So TA, please, could you specify which file do you want to check again?
Yeah, I'm going to show the, probably it could be, let's see. Maybe this one's here. It was in Spain. So you can get the data. This was the example file. And this is the general website. Well,
let's wait. TA, if he wants to share his question again. So in the meantime, Torin Miner asks if you could explain more about how to import scanned building height data.
Yeah, sure. I mean, we're actually running that investigation right now, and the way we are doing it is it's a little bit manual now. So we fly a drone, we do a photogrammetry, and we point cloud, and we bring that data in Rhino, and we are writing a script in Grasshopper to extract those heights. based on some known references, if that makes sense.
Yeah, sure. Okay, this is from myself. So how about the data that you download from the shape files? I mean, the building, are the 2D curves always closed, for example, or?
Yeah, so that's why I would generally download governmental data, because those data are verified with several checks, and they are closed polylines. Sorry, they are points that when we pass on the polylines and we close it, they are fully functional. Rarely you will find governmental data that are missing points to close a polyline.
Good. Okay, that's nice. So we have a user, Edward Petriu, who says that he's having problems with the link you shared. I'm not seeing the model on this link.
Okay, that's strange. Does anybody else has that problem? So I see a lot of people here. I'm guessing it works quite fine. But I'm happy to follow up later on, as always, with anyone that might want to have a look, a demo, or even going through the presentation.
Okay, so yeah, TA, the user who wants to know the link you showed, but we didn't know which one. I meant the Grasshopper script. Would you share it? And the link to the website with the world map to download the GIS data.
Yeah, sure. So the link to the website with the world map, I already shared a little bit above. Sorry, no, I didn't. Excuse me. Let me show that. Yeah, so this is what we created. Let me quickly do a share link. Okay, yeah, this is the governmental websites. Okay, I see that Edward resolved the problem by switching to another browser. That's good, thanks. So for the Grasshopper script, I'm not sharing it as is, but with the handout that I'm giving away, you can follow the whole process, and I have indicated everything that is going on in that presentation. Yeah, I hope that's okay with people.
Good. A good question from Johannes. Have you tried to integrate REST GIS servers into your workflow?
Well, because I do that not so many times the last couple of years, because we are focusing on developing these solutions. I would love to at one point to integrate the servers directly into my workflow, but there's always a possibility to do that, because Heron gives you that opportunity, the plugin in Grasshopper Heron, which, by the way, reminds me that I should share I think that Discord. Yeah, well, this is it. This is the public Discord, and they are really active. Brian Washburn is doing a great job at introducing and maintaining all of that.
Is it open source?
Yes, yes, it's open source. It exists in Rhino, for Rhino, but I found the latest ones to be always published in Discord and in GitHub. I can copy that invitation and paste it again here. So this is our Discord channel.
Okay. So TA, I'll share the handout in the follow-up email that I'll send you in a few days, okay? So when Mario send the handout to me, I'll prepare the follow-up, and all of you will be able to check it out. Sweet. Marios, which like technologies are behind your website?
So we developed our own proprietary algorithm when it comes to processing these the formats. We do currently IFC and 3DM, and the reason for that is that it needs a lot of well, we did a lot of work to develop these to shrink down the file size so that it streams quite well on the web. Because in reality, when you work in big projects, you have big formats and big sizes of 3DM files. And well, other than that, we have 3JS, well-known platform to host the the 3D environment. Mm-hmm. Yeah, generally everything else we have built ourselves.
Good.
If I'm forgetting something, probably my co-founder Harry will jump in.
Okay. So any questions? Any more questions from the attendant? Okay. So I think that is all for today. So Mario, thank you very much for your work and congratulations again. I mean, great work.
Thank you very much. Nice to see you.
And yeah, to the attendants, let's see in the next webinar in some weeks from now. Okay. So thank you very much to all of you. Marius, thank you again.
Thank you. Anything you need, contact me.
Thank you.